Hello my dear students, welcome to NAK Academy. This is the second video of algebraic fractions, so in which I am going to explain one more example related to algebraic fractions, and we will be moving forward towards multiplying algebraic fractions. So those who are not watched my previous video, please do watch, and don't forget to subscribe my channel in NAK Academy, and please like and share our video. Another example for your better understanding. See the length of this question. So at once they have given the binomial expressions. So as you can see, two denominators with two different binomial expressions. So the moment you saw the question, you might think, oh my god, how am I going to do this? It's very simple. As I said, you must have the knowledge of binomial expression, factorizing these binomial expressions. So if you have failed to factorizing these binomial expressions, you will not be able to do this question. So therefore again I am recommending you, I am advising you, work out all the binomial expressions, factorize it, get thorough with it, then you will be able to solve these algebraic fractions too. So I have included the working for these binomial expressions. Now as you can see, so let's take the term separately. X square minus 9x plus 20. So you know the last term or the end term is 20 and the coefficient of x is 9. So the way I must factorize is I need to get the product of 20 in a way the two numbers should match the coefficient of x as well. So if I say the numbers are 5 and 4, yes, 5 multiplied by 4 is equals to 20. Similarly, it must satisfy the coefficient of x, which is minus 9. So how I can derive to minus 9 is minus 5 minus 4 is equals to minus 9. Similarly, minus 5 multiplied by minus 4 is equals to plus 20. So both the sections are satisfied. Factoring satisfied, which is minus 5 multiplied by minus 4 equals to plus 20. Similarly, the coefficient of minus 9 also comes with minus 5 minus 4. So I factorize in a way x square minus 5x minus 4x and plus 20. Now I have four terms where I can pair each term. I can pair one x square minus 5x as one pair, and the other pair is minus 4x plus 20. So out of these two terms I can see x is a common term, so when I take x out I get x minus 5. Similarly, in order to make x minus 5 with the second pair, I must take minus 4 as a common. So I ended up with the terms as x minus 5 and x minus 4. So this is not a rocket science, because this is very simple solving this binomial expression, because you have already learned this in grade 10. So here you are just applying those binomial expressions what you have learned. So since these working also not required in the examination, just for the explanatory purpose I have included this working for you. So as you see the binomial expressions, you will be able to find out the factors, and you should be able to find out what are the two values with the positive and the negative which satisfy the coefficient of x, as I explained in this binomial expression. So the factors, I get x minus 5 and x minus 4. Similarly, I need to take the expression x square minus 11x plus 30 also, and I must factorize this in order to solve this algebraic fraction. So as you can see, the last term is 30. So the factors I get 5 and 6, that is minus 6 into minus 5 equals plus 30. Similarly, to get the coefficient of x, I get minus 6 minus 5, which is equals to minus 11. So I expand the term as x square minus 6x minus 5x plus 30, and as I mentioned in the previous question, I pair each. X square minus 6 is one pair and the remaining pair is minus 5x plus 30. So as you can see, x is a common term, so I take x out of these two, then I ended up with x minus 6. Similarly, in order to make x minus 6 here, I take the common term minus 5, or in other words, if you take minus 5, automatically the remaining terms you ended up with x minus 6. So the fractions are x minus 6 and x minus 5. So these fractions now I need to apply over here, so that it is easy for you to solve this algebraic fractions. Now still we are not ended up with this, because as you can see the denominators are different still, so we need to find the LCM. So LCM is not that much hard. So you can see these fractions and you can find, okay, x minus 4 is one term that you need to take, x minus 5 is another term, and the x minus 6 is another term. That's all about LCM. So we shouldn't repeat x minus 5 twice unless a square is mentioned, because it is only a single x minus 5 mentioned in both the fractions. So we take only one x minus 5. As you separately do this LCM, you will understand very well. So now the denominator terms are x minus 4 into x minus 5 into x minus 6. That value I divide by here over here, that is x minus 5 into x minus 4. So the remaining term would be x minus 6 minus 1 times of. Similarly, I can eliminate x minus 6 with x minus 5, so then I ended up with x minus 4. Now I can simplify the numerator, that is x minus 6 minus x, and again minus into minus is plus 4. So make sure you take the correct operator when you take the product, otherwise you will end up with the incorrect answer. Now you can simplify x plus x with minus x, so your answer would be minus 2, because minus 6 plus 4 is minus 2 over x minus 4 into x minus 5 into x minus 6. So this is how you simplify a given algebraic fractions with the denominators includes a binomial expression. So these are some of the review questions I have did for you. So now we'll discuss multiplying algebraic fractions. So initially we have discussed on how to add and subtract a given algebraic fractions. Now we are going to multiply given two or more algebraic fractions. So let me take a very simple example first. X over 4 multiplied by x over 5. In multiplication and dividing algebraic fraction, one of the greatest advantage is you don't need to find something called LCM here, because LCM is applicable only for addition and subtracting, or adding and subtracting fractions, or it can be normal fractions or it can be algebraic fractions. So when it comes to multiplication, simply you can multiply the given numerator values and you can multiply the denominator values. As long as if there are values to be simplified, yes, you can further simplify and you can multiply. So you don't need to worry about something called LCM over here. So x multiplied by x is equal to x square or x to the power 2. 4 multiplied by 5 is equals to 20. So this is a simple example. So let me take another example. X over 4 multiplied by 20 over x square. Now this question also you can directly multiply the numerators and the denominators, but always double check, is there any terms can be simplified further. In other words, you can cancel. So as you can see here, 20 and 4 you can divide by 4. Also you can divide or you can eliminate 1x. So if I cancel 1x here, so here you get 1 and here you get 1x. If I divide 4 by 4 is 1, 20 divided by 4 is 5. So 1 over 1 into 5 over x, which means my answer is 5 over x. So if students write 20x over 4x square, still it is correct answer, but it is not further simplified. So you have to make sure you simplify to the smallest and you write the final answer, so examiner will have a good understanding about how you are dealing with this algebraic fractions when it comes to multiplication and division or whatever. Okay, now let's go to another example. So I'm little by little advancing the questions for your understanding. So let's take the third example. So what is this? So you have 2 over x plus 3 multiplied by x square plus 3x over 5. So as you can observe, the second fraction, the numerator part, you have a common term under x square and 3x, which is x. So first fraction you can write as it is because you don't have anything to take out. But in the second fraction you can take x out, then you will see some kind of a magic where x plus 3 comes. So simply you can cancel x plus 3 and x plus 3 over here with these two. So as I said, x is a common term, so the x plus 3 can be divided. So when you cancel x plus 3 and x plus 3 over here, the numerator remaining terms are 2 and x2 multiplied by x, and the denominator terms are 1 and 5, 1 into 5. So your answer would be 2x over 5. See, it's very simple. So the moment you do not recognize that x is not a common term here, you will not be able to solve this problem. So as I said, it is important for you to learn factoring of algebraic expressions, solving binomial expressions, and finding LCM for given algebraic terms. So go through those lessons again and do couple of questions and do some revision and get the thorough idea and the knowledge of it. Then you can easily attempt these questions without any hesitation. So let's discuss another example question. So I thought of taking some exercise or some questions from your textbooks directly, so that it would be more convenient for you rather than I am taking different questions. So if I directly take some questions from your textbook, so it is easy for you to practice as well. So there are 10 questions given in your exercise 7.1, which is in page number 82. I'm not going to discuss all 10 questions in this video session, but I have picked up few questions from the basics to the advanced. So as you can see, the very first question you feel like it's a basic question, and if you go to question number 5 or 6, it is something medium level question, and if you go to question I and J, it is something like little advanced questions. It is not that advanced, as I say. It's as long as if you know how to apply factoring of these algebraic terms, it is super easy for you. So let me take the first question. Let's say 6 over x multiplied by 2 over 3x. So as I mentioned you can simplify here 3 and 6 you can divide. So 3 you can cancel, 3 divided by 3 is 1, 6 divided by 3 is 2. You cannot further simplify any terms. If someone asks, can I cancel x and x? No, you can't, because both the x are in the denominator. When we divide, always remember we divide the values against numerator and the denominator. It is not numerator versus numerator or denominator versus denominator. It is always numerator versus denominator or denominator versus numerator. So here the numerator value is 6, the denominator value is 3. So I can divide by 3. 3 divided by 3 is 1 and 6 divided by 3 is 2. So I ended up as 2 over 6 multiplied by 2 over x multiplied by 2 over x, which means 4 over x square. So this is something, a basic level question. Let me take another example or another question in that exercise. 3a minus 6 over 3a multiplied by 1 over a minus 2. So as I mentioned you earlier, here you can find 3 is a common term. So you can see 3a minus 6 in which 3 is a common term. So when I take 3 out, within brackets I can write a minus 2. So the numerator value comes as 3 times of a minus 2 over 3a multiplied by 1 over a minus 2. So as you can see, a minus 2 and a minus 2 can be eliminated. I can cancel. Also 3 can be eliminated. This 3 and 3 can be divided. So the numerator here clearly I ended up with 1 multiplied by 1 is 1, and here a minus 2 and 3 already cancel, so the remaining term would be a. So my final answer would be 1 over a. Thank you for watching this video. Please like, share and subscribe our channel NAK Academy. Simply you can click the bell icon. And if you have any need any further clarifications on this, leave a comment. So I'll be continuing this lesson with my upcoming videos.